Hey guys, so this is calculus for today. We're going to be working on some new stuff. Last week we worked on the textbook we've been following. It's chapter 41, integration using algebraic substitutions. I think a lot of students found this relatively simple. If you recall, what we basically do is we have integration. All right, that's what we're going to be doing for this test. And this section is really if you have a function such as cosine or sine or tangent, and then you have something within the brackets. All right, what we can do is we can set up a function where u becomes what's equal to the brackets. And if we take the derivative of that, we rearrange it, and we substitute back in the formula. Then what we can do is we can use trig substitution. These would be the tables that I've kind of passed on from the last test, where we can use the integral of cos. We can substitute in what cos would be through that integration, and again, we can evaluate u du afterwards, and then we have come up with our final function that looks something like this. So hopefully this will jog your memory. We're going to take integration one step further. We're going to skip ahead here to chapter 43, which is called integration using partial fractions. Now, in the test, I think you'll be able to recognize this relatively simple because integration using partial fractions is going to look something like this, where you're going to have something that's kind of relatively large equation, both on the top and bottom, and then we have to separate it into its own pieces and then integrate, which is what I'm going to show you how to do today. So like last week, what I'm going to do is I'm going to run through an example first to hopefully, to show how this works, and then I'll go through a couple of questions to help you guys along. So in Teams, I've made a whiteboard under April 8th. I've copied in some of the things that might be important for this chapter. All right, so try not to get too lost in all these pieces, and I'll refer to them in this first question, and then I think you'll see some of the stuff that's valuable. So for partial fractions, you guys would have done this probably in grade 10 or 11, not the integration, but the actual solving of partial fractions. All right, some of you may have seen this, in your high school days, or I guess you've taken math in previous courses here, where basically if we have a function, okay, and if we have, say, a cubic or a binomial equation on the bottom, how we can break it up into its form of partial fractions. And what we're going to do is we need to do that in order to integrate. All right, so there's three kind of rules here. I'm not going to spend too much time going through this. I do find that this is probably the hardest part than it's harder than doing the integration. My thought here is I'm not going to go out and find crazy different formulas for you guys, or sorry, different questions for you. It's more just, if you can evaluate something like a binomial, maybe a cubic, although that's not really what I want to do, is really a binomial here on the bottom that you can separate them into two, okay? So let's go through this first question. Hopefully it'll show you what steps need to be done. So first what I'm going to do is I'm going to run through the problem, all right, how to do the process, and then I might focus a little bit more on this piece, which is separating out the fractions, because I know for me it was a while since I've done this, and I know that there's some ways that you guys have probably learned that help simplify this, but if you haven't learned, I'll go back and review maybe how to do this again so that you guys know how to do it. So this would be a type of question that you'd see on your assignment. All right, so what we have is determine basically the integral of 11 minus 3x divided by x squared plus 2x minus 3. So what should pop into your head is that this is not like last week, all right? There's no cosine or sine function that's in front of this, all right? It's a, basically it's two equations over top of each other. And so we need to figure out how to integrate this. So the first step for this is we need to separate the top and the bottom into something called partial fractions, all right? So I'm going to show this step after this question on how to go through this process, but 11 minus 3x over x squared plus 2x minus 3 can be separated into 2 over x minus 1, subtract 5x plus 3. And if you don't know how to do this in your head right away, don't worry about it. I'll review it in a minute. But that's basically the goal here, is we need to separate these two items out into its two sections. How do I know it's two? Usually it's because there's a squared here. If it's a squared, you're going to get 2. If it's a cubic, usually you're going to get 3. Again, up here, there's some rules here on how to separate these out. So let's go through the integration bit. Okay, so once we have these separated, okay, this is what it's going to look like as it's separated. So we're starting the integral. So once we're here, it actually becomes pretty straightforward on how to do the integration. So if we have 2 over x minus 1, right, we're going to get 2 ln x minus 1. Now you might say, like, well, how did I go from this to this? Well, last week we actually used some of these formulas. And so what's going to be a common one is when you have a number over a fraction, right, where there's x in the denominator and a number in the numerator, right, this number in front, okay, is going to come down here, right, so it's going to come down into the front. X minus 1, okay, what we need to do to evaluate this is there's actually a simple formula which we can substitute these in, whereas when you have 1 over x, or if we have 1 over x plus, or x minus 1 in that case, this function, okay, represents x, okay, here. So we have x minus 1, try to make this more like a bracket. So this goes in the denominator. If we have 1 over some function, then we can equate it when we do the integral of it to ln x plus 1. So this is really ln the function inside plus c. So here we have 2, and then in the case of ln, so this would be our x term here. Okay, so we take this goes here, and basically we rewrite it as our function, right? This is our function of x. And so if that makes sense, then you can probably see that this one here, this is 5, so our 5 again comes down in front, and then we have an x plus 3. So our x plus 3 is our function of x, so we have ln x plus 3. All right, so our final equation here is 2 ln x minus 1 minus 5 ln x plus 3. Okay, so the hardest part for this with the substitution is that this piece in the bottom becomes basically our x function in this equation. All right, so this becomes our x. And then when we rewrite it, we have our ln, and then this would be our x function, right? So this is x minus 1. We just substitute that in for x, and then away we go. Okay. Again, pretty straightforward on how to do this. There's not really too many tricks. The hardest part I think that you guys are going to find for these types of questions is this first bit, okay, which is the separating out the partial fractions themselves. So I'm just going to spend a second here explaining that. So I've copied over how to break down partial fractions. So this is actually in the textbook, and if you have the textbook, it's back in chapter 2, right? So this says resolve 11 minus 3x, x squared plus 2x minus 3 into partial fractions. Right, so this goes through how to do that. So let's go through if you've forgotten how to do it. If you remember how to do it, you can, fast forward the video until I do the second problem. But if you want a quick review, then I'll go through it now. So the first piece is understanding how to factorize the bottom of the equation. And if you forget how to do that, all right, let me just bring this over here, right? So what we need to basically do for this, all right, is that the way I remember this is if we have, I'm going to try to write this out, steps. So we have x squared, and I'll put that in a second, plus 2x minus 3. Okay. So what we need to do is we need to find, in this case, two numbers that multiply, to equal minus 3. equal minus 3, or any number in the very back of the equation, okay? It's being wonky. Okay, and then for the 2x bit, what has to happen, and this is a rule, so they both have to satisfy. The 2x is both numbers have to, whatever multiply together, have to equal 2. Equal minus 3 and add together to be plus 2. Okay, so two numbers that multiply that equal minus 3 and add together to be plus 2. All right, so there's only a couple options, and that's what's nice about this. So our combination is basically two numbers that add to 3. We have 2 and 1. Okay, two numbers that add together, two numbers that multiply to minus 3. We have 3 and minus 1. Okay, we have minus 3 and 1. All right, so if we look at 3 and minus 1, if we were to add these two together, okay, we have 3 plus minus 1, which is equal to 2. And then if we have minus 3 and minus 1, you can see that this isn't going to work. If minus 3 and minus 1, they multiply together to be minus 3. But when we add them together, we have minus 3 plus 1, which would equal minus 2. Okay, so we know that doesn't work. So we need to satisfy both arguments, and this one doesn't work, okay, because of minus 2. All right, we needed to add to be plus 2. So when we have these two numbers, okay, we have x is equal to 1, and we have x is equal to minus 3, or what they can be written as is fractions. And what I want to take it from is switch it over to here and say x minus 1 and x plus 3, when we factorize those together, when we multiply them together, will give us x squared plus 2x minus 3. Right? So that's what this is basically saying. The denominator factorizes as x minus 1 and x plus 3. Okay, so what we can do is if we skip down here, if we have 11 minus 3x, x squared plus 2x minus 3, this factorizes into x minus 1 and x plus 3. Right, so if we satisfy this, we can move to this. Now, to separate these two, what we want to figure out is, let's figure out what the two top numbers are above the fractions if we were to, say, add them together. Okay, now this is where, again, if you've done this before, hopefully this is a review. All right, so what we can do is if we set A and B above, these are just placeholders for us to figure out how to solve this. So they're constants, right, to be determined. What we can do is we can have x minus 1 over x plus 3. And if we have A times x plus 3 plus bx minus 1. So the way that we want to bring these together is we multiply this up here and this up here. Okay, so that's a way that we can, say, combine these together. And so if we keep following down here, okay, so since the denominators are the same on each side of the identity, then the numerators are equal to each other. Thus, 11 minus 3x is equal to a over x plus 3 plus bx minus 1, right? Because this and this on this side are equal to this and this on the other side. What we do is we can cross these off. Why? Because if we were to cross multiply, if we were to bring this over here, x minus 1, if it came over here, we would cross this off. If x plus 3 came over here, they'd be able to cross it off. So we can cross off these guys. And then what we're left with is 11 minus 3x is equal to a times x plus 3 plus b equals x minus 1. Now, at this point, we know that we can substitute in x equals 1, or we could substitute in x equals minus 3 and solve this equation, right? So we basically have two equations, or we have one equation with two unknowns, but we have two variables we can put in, all right, to solve for A or B. So once we do this piece, so once we've done our factorization and got to this step, we can put 11 minus 3. We put x equals to 1 in for x. Here we have A. Here we have x plus 3, so we're going to put 1 in here. And for our other equation, we have plus b, where if we put 1 in here, we get rid of b, and then we can solve for a. So in this case, a is equal to 2. All right. Now with a equal to 2, we could put a back into the equation and solve for b. Sometimes it's better to do it this way, which is to put the other x variable in and solve for b. Only being is if you get a wrong, it will get b wrong. So if we run the equation again with x equals minus 3, this time we can substitute that in to the original equation. So we have 11 minus 3x. We put minus 3 in here. We have a. If we put minus 3 in here, we have minus 3 plus 3, which is 0. So we get rid of a, and then we put x in for minus 3, minus 1. So that's where you see here. We solve for this, and then we have b equals minus 5. Again, if you look at all these steps, right, we had to go through here, here, and all of this to get into our partial fraction. This is what takes the most amount of time for this question. All right, the actual integration part, we're going to be using primarily this equation for substitution for this piece, but the partial fractions is what can take a lot of time. So again, the expectation is you'll be able to do this. So if this is, you need some review here, please take it in this assignment because we'll need to know how to do this for next week. Okay. So I'm going to start another question, all right, and then we'll use this partial fractions. I'll go through how to do it in the example. For you guys at home for this time, I know you're going to ask, do I need to do it? I would show your work, get used to doing it, because on the test, I'll ask for how you found those, all right? At least the pieces on how you separate them, okay? So let's go to our second question, which is this one. So I'm going to get it set up. I'm just going to pause the video for a second and run through the pieces, and then I'll talk about it. Okay, so for the first step here, you know, what we need to do is factorize this. And if you have the textbook, I would try to, you know, look past it because they factor everything right away because they've done it earlier in the chapter. So I would try doing it yourself. So we have x squared plus 1 divided by x squared minus 3x plus 2. So we're likely going to have to factor, you know, both the top and the bottom, all right, in order to separate these out. First piece is figuring out what the bottom is. So we have x squared minus 3x plus 2. All right, so we need to figure that out. So I just rewrote it here, x squared minus 3x plus 2. What two numbers multiply to equal 2 and add together to equal minus 3, right? So there's really only two combinations, all right? We have 3 and 1, right? Those are really the only ones that can be used because, sorry, not 3 and 1. We have 2 and 1, I should say, because 2 times 1 is 2, and yeah, that's all we have. So we have 2 and 1 are the numbers, so they need to add together in order to equal minus 3. So you can probably put your head together and say that, well, minus 1 plus minus 2 is equal to minus 3. And if we multiply minus 1 times minus 2, right, then we get 2, right? So those are our two factors. So we have x is equal to 1, and we have x is equal to 2 in this case, right? Or factorized, we have x minus 1, and in this case we have or x minus 2, right? So it means we take 2 to the other side. So the bottom part of this, so if we kind of write this like this, what we have here is if we have bracket x x minus 1 times bracket, getting a little off my page here, x minus 2, right? So that's the bottom. Now the next part of this is we have to figure out how to factorize the top. Okay, so we have this x squared plus 1. So I'm just going to rewrite this underneath here, and then I'll unpause and I'll walk through that piece. Okay, so for the first step here, what we have is x squared plus 1 over top of x minus 1, x minus 2. All right, then we're going to set up an equation, basically a over x minus 1 plus b over x minus 2. So this is like this example, the very first one that we did. All right, so we had 11 minus 3x over x squared plus 2x minus 3. We found out how basically to factorize these, and then we set up this equation, a over this and b over this. The next step, which I'm going to run into, is we need to do some cross multiplication. So basically we need to bring up this number, multiply this, and then this one times this. We're going to bring this up here and then this up here. Once we've done that, then we can set this equal to x squared plus 1, and then we can solve for our equation. So I'm just going to take a pause here, and I'll write that out, and then we'll solve it. Okay, so I've rewritten this. All right, so technically we have this like 3 equal sign, which is basically just saying that we're taking our steps to go through this process. So what I've done is cross multiplication. All right, x minus 1 has come up, x minus 2 has come up, so it's written as a x minus 2 plus b x minus 1. We have common denominators, right? So once we have common denominators, what we can do is we can set this equal to x squared plus 1. And this 3 bar. Then we have a x minus 2. Right, and then plus bx minus 1. Okay, in brackets. Right, and so the process is like this, what we're going to do for the previous question, where if you recall what we did is we put in our the factorization that we've done. So in this case, we found x equals 1 and x equals 2. We're going to go through that process. We're going to add in x equals 1 first to here, and you'll see that it'll cancel b out. And if we solve, we can get a, and then we can put in 2 in for x as our next one, and then we can get rid of a, and we can solve for b. So I'm going to go through that process, and I'll write that out now, and then you guys can, then I'll review it with you. Okay, so when I entered x equals 1 and solve for a, all right, so I put 1 in here. Don't forget it's still a squared, but you know we still have to evaluate it. So we have 1 squared plus 1. Here we have a times, and we put our x as 1 in here, so we have 1 minus 2 plus b, and so we have an x here, so we put a 1 in, so it's 1 minus 1 is 0. So this term cancels. So what we're left with is a times 1 minus 2, which would be minus 1. Right, and on the left-hand side, we have 1 plus 1, which is 2. Divide by minus 1 both sides. A is equal to minus 2. Right? So that is the answer for the first one. And I'll write out the second equation, and I'll solve that now. Okay, so when we get down to factoring, so I just, moving along here, we have enter x equals 2. And solve for b. So if I put 2 into our equation, so we have 2 squared plus 1. Oops, I should have put that as 5 here. 5. So 2 plus 1, sorry, 2 squared is 4, plus 1 is 5, equals a, and we have 2 minus 2, so a goes away as 0, plus b, which is 2 minus 1, which is this 1. So in this case, we have 5 equals 0 plus b, and so we have b should be equal to 5. So I'll rewrite this equation, and yeah, then we can do the integration. So once we substitute this back in the original equation, we make it x squared plus 1 over x minus 1 and x minus 2. This, based on what we've done here, we found that a is equal to minus 2, b is equal to 5, so we rewrite it like this. Now, at this point, what I would say to you guys is once you factorize it, you may want to do a check here, okay? And by checking, what you're basically saying is, okay, do these numbers, does it equate back to this equation. So this has nothing to do with integration, nothing to do with derivatives or anything else. It's just when you factorize something, you can work backwards, and this was our original equation, and figure out if it works. All right, and what you're going to see here is it's not going to work. Okay, and there's a reason for this, but I wanted to show you this method because A and B are correct, but we are missing something. So if I check this, what I want to do is I want to cross multiply. So I take x minus 2 and I bring it up here. I take x minus 1 and I bring it up here. So what we're trying to do is combine these into one fraction. So it's written here, all right, x minus 2 comes up and x minus 1 comes up here. That means once I can cross multiply, it means that we can bring these two fractions together like this. And so once I do this, I have minus 2 times x, which becomes minus 2x. Minus 2 times minus 2 is plus 4. Then I have 5 times x, so 5x, and then 5 times minus 1, which is minus 5. Right? And I haven't written it all out yet, but let's add these together. So I have minus 2x plus 5x, so I have 3x. And I have plus 4 and a minus 5, so I have 3x minus 1. And I have x minus 1 over x minus 2, all right? So you can see here that we don't have what we started with, right? And this might happen to you, right? You've done something wrong, and this is a way to check. So what happened is we have 3x minus 1, but we're supposed to have x squared plus 1. So the thing is what happened? So I'll explain that right now. Okay, so we figured out something's wrong. What we're going to need to do here, all right, is when we have a polynomial term, so when we have something that's, say, an x squared term in the top and an x squared in the bottom, right, we're going to need to do something that's called polynomial division, all right? This is not something that, again, I want to focus too much time on. We just need to know the simplest way how to get through it. My suggestion is Khan Academy has done a polynomial revision. I watched the video. It's pretty good. Just to refresh, if you want some more examples of this, chapter 1 and 2 in the textbook, all right, go through how to do polynomial division and how to figure this out. What I'm going to do is I'm going to trust that you watch this. I'm going to write out the next term here and how to get this, and then we'll go from there. So I trust that you watch the videos. I would really recommend watching this video if you haven't, because it's going to be a really good refresher for you guys, right? Maybe you've done this recently and you can understand it. To be honest, I had to dust my memory off from this. This is the solving of this problem into partial fractions, okay? So it's in the textbook in chapter 2. So this was our original equation, except we're asked to integrate it. So we have to get the partial fractions to integrate. So you have x squared plus 1 over x squared minus 3x plus 2. This is the long division, all right, way of doing this. And you might think, oh man, do I have to do long division? You don't really. You just have to understand in a basic format how to do this. So if you've watched the video, you'll know that we write out what's in the denominator, all right, here, and it's being divided into here. And you'll know that x squared minus 3x plus 2 here can only really go into x squared plus 1 once. And our remainder here is 3x minus 1, right? So you remember the remainder in long division is, what can't be divided out. So if we rewrite this as a partial fraction, we have x squared plus 1 over x squared minus 3x plus 2. This is equal to 1 plus 3x minus 1 over 3x squared minus 3x plus 2. Okay, so we have this 1 out in front, all right, which is this. This is the remainder of what we couldn't divide out. Now, what was leading up to this, into this is the format for solving A and B. And so the reason I'm bringing this to your attention is that there are a few, I guess, rules for integration when we can't just follow the standard method like I did in the first problem. So when we have, like I said, a polynomial or a polynomial, we're going to have to do long division to see what the actual partial fractions are. If you follow along here, all right, so after we have this 1 plus, we go through the same process of figuring out what a and b is. So you can see here, we start with this, okay, 1 plus 3x minus 1. We factorize the bottom, x squared minus 3x plus 2. We know that's x minus 1 and x minus 2. We did that at the very beginning. We then separate the fraction into a plus b over the two fractions, okay? And then we solve for a and b, right? Now, this case, a and b, like we did in the very beginning, is equal to minus 2 and 5. It just, the one thing that changes in this problem is that we have this 1 plus here, okay? So what we need to do is we need to write back in our formula 1 plus our a and b term. So I'm going to do that now. Okay. So I've rewritten this, all right? So we have x squared plus 1 over x minus 1 over x minus 2 yields a over x minus 1 plus b over x minus 2 plus 1. We substitute a back in. So we have minus 2 over x minus 1. We substitute 5 back in, 5 over x minus 2, and we have plus 1. In the textbook, this is written as 1 minus 2 over x minus 1 plus 5 over x minus 2. All right, so the 1 comes to the front. Now, you should be asking yourself, is this done? And the answer is, we have factorized this. Now we need to integrate it, right? So I'm going to write out the integral here, right? And then we'll integrate it. And I hope that you'll see that the integration part is actually the easy part in this. It's this getting the partial fractions right that can take some time. There are 4 rules for this. I'm going to keep this hopefully relatively simple. The worst we're going to get are these like a polynomial or a polynomial. There are many different styles of these types of problems that can be broken down in 4 rules. Again, this is calculus light. I'm just going to show you that we have basically what we have in question 1, all right, which is basically a non-polynomial, all right, over the top of a polynomial. In this case, we have a quadratic over a quadratic, or say an x squared number over an x squared number, where we need to do this long division format, right? So this is, I hope to be the toughest that we need to see, both on the assignment and on the test, okay? So we do need to follow this format for the assignment, all right? And you may see one of these on the test. So I do want you guys to at least learn this format. So let me write out the integral and then we'll go through it. Okay, so we've broken this up into fractions. So this was the original question, right? X squared plus 1 over x squared minus 3x plus 2. This is what we've now solved for. So we have 1 over 1 minus 2 over x minus 1 plus 5x minus 2 dx, right? I'm just going to bring in the textbook question, or I'm going to copy it in because it looks way cleaner than I have it. So it's written in the form, let me just put it in, okay? So this looks just a little bit cleaner as I write over top of my stuff. Okay, so this is what we have. Now, if you've been following along, and if you made it this far, congratulations. Question 1, you'll remember that we can use, all right, our substitution rule right here. Okay, we have integral of 1 over x dx, where x is basically whatever the function is in the bottom. So we're going to use that to integrate our question down here. Okay, so we know that this is going to turn to a ln number. This is going to turn to a ln number, right? Ln meaning the ln term, right? But what happens to this one variable? Okay, so let's look at this. So we're going to pull this in from the textbook. All right, so I think you guys, you know, from the first question, again, this is basically saying the 5, all right, stays out in front. The x minus 2 is going to go into where the x function is for ln, right? Similar for this, the 2 comes out in front, all right, and then the x minus 1 term is here. But let's look at this x minus 2, all right? Okay, so this piece here, I don't technically agree with the textbook. What this should actually be written as is x. So when we integrate 1, all right, so we integrate 1 and 1 becomes x. So it should be x minus 2 times, all right, ln x minus 1. All right, x minus 1 here plus 5 ln x minus 2, okay? Plus c. Okay, so this minus 2 should just be attached to this. And that's just like how we did, problem 1. It was just like this. Now, this was a really long question. And I would say that probably the most technical that we've done in a while, really, because we've been using a lot of equations for substitutions. And some of you guys might like the substitutions better, that we did last time, because like when you have sine and cos, because we have these tables that you can basically just plug in the whole, answer. Whereas a problem like this is, you're getting into, substitution, not really substitution, sorry, like algebraic equations and all that. So again, this was a pretty lengthy one. I think you have enough to start. So assignment 1 is really, there's questions on 2 pages. With these 2 problems, you should be able to do the first set of problems. Tomorrow, we're going to get into the next step in calculus, which will do the back pages. My suggestion is try the problems on the assignment after you've seen this, and hopefully if you get the right answers, just check the textbook. And if you have any problems, please let me know. All right.